We've seen how to calculate partial derivatives using derivative rules. Let's see how we can also estimate partial derivatives just based on a contour plot. Remember what these partial derivatives calculate, or what they tell us, is the rate of change in the whatever direction, right? So either in the x direction or the y direction. So to figure out if partial f partial x and partial f partial y are positive or negative at this marked point here, we just need to figure out, as we move in each direction, is the function increasing or decreasing? And we can use the contour plot to figure that out. So first of all, what point is this? It looks like in the y direction it's at about 3, and in the x direction it looks like it's 1.5 maybe, so 3/2. Okay, so let's estimate partial f partial x evaluated at the point 3/2, 3. Okay, of course the rate of change depends on the x and y coordinate that you choose, and I have chosen 3/2, 3. So at this point, remember we're thinking about moving in the x direction. To figure out if the function is increasing or decreasing, we have to write what on a contour plot tells you about the output values of the function. It's the labels for the contours that tell you the output values of the function. So at this point, 3/2, 3, we're sitting at the output value 3, so height 3. And as we move rightwards, we're moving towards this contour over here, which is output value 2. So that's lower. And if we back up to the left, we get to the higher contour value 4. So as we move rightwards, our contour values are getting smaller, and so this derivative must be negative. Okay? Let's do the same thing in the y direction before we actually estimate what one of these is. I think we'll only estimate one of them just because that's enough to give the idea. So in the y direction right now, we have to imagine that we're moving upwards on the graph like this. So again, we're on the contour 3. When we move upwards in the positive y direction, we get to the contour 4, so we get to a higher contour. If we move backwards in the negative y direction, we get to a lower contour, the contour 2. So as we move in the positive y direction, we're moving from lower contours to higher contours. That means that in the y direction, f is increasing, and so this derivative is positive. All right. So now let's actually try to estimate the derivative in the x direction at this point, 3/2, 3. To do that, well, I mean, this isn't going to be very accurate because we only have a graph after all. But what we can do is actually move to a neighboring contour. Sorry, I said the x direction. So we need to move in the x direction to a neighboring contour, and then calculate the change in f over the change in x for the move that we just made. So the value of the function at our ending point is, right, that's on the contour 2, so 2. The value of the contour that we started on was 3. And then we have to divide by how far we moved in the x direction. So if I scroll down a little so you can see the scale markings, it looks like this horizontal distance is maybe about a half, right? Just estimating very roughly. Okay, so we get minus